Welcome, dear explorers, to Earth with Nature, a sanctuary where we journey through the vastness of the cosmos and the delicate intricacies of our own blue planet. Take a deep breath, let the day's noise fade, and join me in a moment of quiet wonder as we gaze up at the night sky, a canvas of endless mysteries. Today, we're embarking on a slow, thoughtful voyage to unravel one of humanity's oldest questions. How did the universe create itself? How did everything begin? From the explosive dawn of the Big Bang to the silent whispers of distant worlds, we'll explore the origins of existence with open hearts and curious minds. Settle in, imagine the cool night air around you, the stars twinkling overhead, and let's dive straight into the heart of cosmic wonder. Picture this: a time before time, a void so profound that even the concept of before didn't exist. This is where our story starts, not with a whisper, but with a bang that birthed everything we know. The Big Bang, some 13.8 billion years ago, wasn't just an event. It was the universe's first heartbeat, a violent burst of energy and matter expanding into an infinite expanse. Can you feel the weight of that moment? The sheer power as space itself unfurled like a cosmic flower blooming in slow motion. Scientists describe this as a singularity, a point of infinite density and temperature where the laws of physics as we know them cease to apply. It's a concept that humbles us, reminding us how much we still don't grasp. But from this chaos came order. Particles collided, cooled, and formed the first atoms, setting the stage for stars, galaxies, and eventually us. Let's linger here for a moment. Close your eyes and imagine that primal energy, the raw potential of a universe waiting to be written. What does it stir in you? This idea that everything, from the mountains to the oceans, from your very breath to the farthest star, began in a single unfathomable instant. As we ponder this, let's transition to the next chapter of our cosmic tale, where the universe begins to shape itself through a process as delicate as it is powerful. As we drift deeper into the story of cosmic wonder, let's imagine the universe in its infancy, just fractions of a second after the Big Bang. This is the era of cosmic inflation, a period so rapid, so breathtaking, that it stretches the mind to comprehend. In less than a trillionth of a second, the universe expanded faster than the speed of light, growing from smaller than an atom to the size of a grapefruit. Picture it: a tiny seed of reality exploding outward, smoothing itself into the vast, uniform canvas we see today. This inflation, proposed by physicist Alan Guth in the 1980s, explains why the universe appears so flat and why distant regions share the same temperature despite being too far apart to have ever interacted. Isn't that mesmerizing? It's as if the universe had a blueprint, a hidden harmony guiding its growth. But what drove this expansion? Scientists point to a mysterious force, a field of energy that briefly dominated before fading away, leaving behind the seeds of structure. As we marvel at this, let's imagine the universe cooling, particles slowing, and the first light emerging, a glow we can still detect today as the cosmic microwave background, CMB. This faint radiation, discovered in 1965 by Arno Penzias and Robert Wilson, is like a fossil of the Big Bang, a snapshot of the universe at just 380,000 years old. Think of it as the afterglow of creation, a whisper from the past that radio telescopes can still hear. Pause for a moment. Can you sense the weight of that light, traveling across billions of years to reach us? It's a reminder of how connected we are to the universe's first moments. Modern technology, like the Planck satellite, has mapped this CMB in exquisite detail, revealing tiny fluctuations, ripples in the fabric of space, that would grow into galaxies and stars. These planetary science facts ground us in the reality of our origins, showing how chaos birthed beauty. What do you think it would feel like to witness those first flickers of structure, knowing they'd one day become the cosmic neighborhoods we call home? As we reflect, let's move forward in time to see how these seeds of matter began to weave the tapestry of the cosmos, leading us to the birth of light and life. Now, let's journey a few 100 million years after the Big Bang, to a universe still cloaked in darkness, a time before stars, before light as we know it. Feel the stillness of this cosmic void, an ocean of hydrogen and helium gas floating aimlessly. But then, something miraculous happens. Gravity, that gentle yet relentless force, begins to pull. Clouds of gas collapse under their own weight, heating up until they ignite into the first stars. These weren't like our sun. They were colossal, burning hotter and brighter, living fast and dying young in spectacular explosions called supernovae. Imagine the first burst of starlight piercing the endless night, a beacon of hope in an empty universe. These early stars, often called population 3 stars, were the universe's first alchemists, forging heavier elements like carbon, oxygen, and iron in their fiery cores. When they exploded, they scattered these elements into space, seeding the next generation of stars and, eventually, planets like ours. Isn't it poetic? The very stuff of your body, the iron in your blood, was born in the heart of a star billions of years ago. Let that sink in for a moment. How does it feel to know you're made of stardust, a direct descendant of those ancient cosmic giants? Thanks to instruments like the James Webb Space Telescope, launched in 2021, we're now peering deeper into this era than ever before, catching glimpses of galaxies forming just 200 million years after the Big Bang. These observations are rewriting our understanding of cosmic history, showing us a universe eager to create. As we linger on this image of newborn galaxies swirling into existence, let's consider the invisible forces shaping them. Dark matter and dark energy, mysterious players in the cosmic drama. Dark matter, making up about 27% of the universe, acts like an unseen scaffold, guiding the formation of galaxies with its gravitational pull. Dark energy, comprising nearly 68%, drives the universe's accelerating expansion, a discovery confirmed by the 1998 observations of distant supernovae. What do these unseen forces evoke in you? A sense of mystery, perhaps, or awe at how much of our reality remains hidden? Let's carry this curiosity forward as we explore how these cosmic conditions set the stage for worlds like ours, and perhaps countless others. Let's step back now, not just in time, but in perspective, to ponder the deeper meaning of our cosmic journey. As we explore exoplanet mysteries and the origins of the universe, we're not just uncovering facts. We're grappling with who we are and where we fit in this grand tapestry. Earth, our pale blue dot, is a marvel of fragility and resilience, a tiny oasis in an ocean of stars. But what if we're not alone? What if, among the billions of worlds out there, others bloom with life, perhaps not as we know it, but in forms beyond our imagination? Picture a planet where bioluminescent forests glow under twin moons, or oceans teem with creatures that communicate through light. The wonder of such possibilities stirs the soul, doesn't it? Yet, even as we dream of distant life, we're reminded of our responsibility here. Earth's habitability is no accident. It's the result of billions of years of cosmic choreography, from the right distance from the sun to the protective embrace of our atmosphere. Science and technology like climate models and space observatories show us how delicate this balance is. One misstep and we risk losing it all. But this isn't a story of fear. It's one of awe and action. Every discovery, from the cosmic microwave background to the latest exoplanet find, connects us to something larger. It's a call to cherish our world, to protect its beauty, and to keep searching for answers. Think about this. How does knowing we're part of a 13.8 billion year story shape the way you see your daily life? Does it make the mundane feel magical, knowing each moment is tied to the universe's first spark? As we reflect, let's also consider the future. How missions like the European Space Agency's Ariel, set to launch in 2029, will analyze exoplanet atmospheres for signs of life. These endeavors aren't just about data. They're about hope, about extending humanity's gaze and spirit into the unknown. Let's carry this sense of purpose forward as we wrap up our journey, turning our wonder into connection and inspiration. As our cosmic voyage draws to a close, let's linger in this space of wonder a little longer, feeling the weight and beauty of all we've explored. From the universe's fiery birth in the Big Bang to the silent potential of distant exoplanets, we've traveled through eons, marveling at the forces, seen and unseen, that shaped everything. We've stood in awe of the first stars, felt the hum of the cosmic microwave background, and dreamed of alien worlds that might one day whisper back to us. Here at Earth with Nature, our mission is to keep these stories alive, to weave the threads of science, technology, and imagination into a tapestry that inspires. Think of Earth as a lighthouse in the cosmic sea, a beacon of life, fragile yet fierce, reminding us of what's possible when the universe dreams big. Can you feel that connection, that thread linking you to the stars, to the ancient light still traveling toward us? I hope this journey has stirred something in you. A curiosity, a sense of belonging, or simply a quiet appreciation for the mystery of it all. As we return to our daily lives, let's carry this cosmic wonder with us, letting it color the way we see our planet and each other. Before we part, I'd love to hear your thoughts. What struck you most about the universe's origins or the possibility of other worlds? Do you think we'll ever solve the Fermi paradox? Or is the silence part of the beauty? Drop your reflections in the comments below. I read every single one and cherish the community we're building here. If this exploration touched your heart or sparked your curiosity, please give this video a thumbs up. It helps us reach more dreamers and explorers like you. And if you're new to Earth with Nature, hit that subscribe button and ring the bell so you don't miss our next journey. Whether it's diving into planetary science facts, unraveling exoplanet mysteries, or simply marveling at the wonders of our home. Together, let's keep asking the big questions, nurturing our sense of awe, and protecting the only world we know. Until next time, look up at the night sky, breathe in the mystery, and remember, you are part of this incredible story. See you soon, fellow stargazers. As we linger in the afterglow of our cosmic journey, let's dive even deeper into the enigmatic forces that continue to shape the universe's destiny. We've touched on dark matter and dark energy before, but now let's immerse ourselves in their profound influence, feeling the weight of their mystery. Dark matter, this invisible architect, comprises roughly 27% of the universe's mass energy, yet it eludes direct detection, revealing itself only through gravitational effects. Picture it as a ghostly scaffold, weaving through the cosmos, holding galaxies together like an unseen hand. Without it, the Milky Way, with its elegant spiral arms, would unravel into chaos. Scientists infer its presence from the way stars orbit within galaxies, faster than expected if only visible matter were at play. Experiments like those at the Large Hadron Collider and underground detectors such as LUX Zeppelin strive to capture a whisper of dark matter particles, possibly WIMPs, weakly interacting massive particles, but the silence persists. Can you sense the intrigue of chasing something so vital yet so elusive? Dark energy, on the other hand, is even more perplexing, making up about 68% of the universe and driving its accelerating expansion. Discovered through observations of Type Ia supernovae in the late 1990s, it's like a cosmic wind pushing galaxies apart, defying the pull of gravity. Imagine standing at the edge of the universe, feeling this force stretch the fabric of space itself. What would that vast, unstoppable push evoke in you? Theories suggest dark energy might be a property of space itself, tied to the vacuum energy described by quantum physics, or perhaps a dynamic field called quintessence. Missions like the Euclid satellite, launched in 2023, are mapping the universe's structure to better understand this force, peering into the cosmic web of galaxies for clues. These planetary science facts remind us how much of reality remains hidden, urging us to keep questioning. Reflect for a moment. Does the mystery of dark matter and dark energy make the universe feel more alive, almost as if it's playing hide and seek with us? As we ponder this, let's shift our gaze to how these forces influence the formation of cosmic structures, setting the stage for the very possibility of life across countless worlds. Now, let's trace the intricate patterns woven by dark matter and dark energy, zooming out to behold the universe's grand architecture, the cosmic web. Imagine a vast three-dimensional tapestry, where galaxies cluster along glowing filaments, separated by immense voids of near emptiness. This structure, born from those tiny fluctuations in the cosmic microwave background we spoke of earlier, owes its existence to dark matter's gravitational pull, which drew ordinary matter into dense nodes over billions of years. Picture these filaments as rivers of light in an otherwise dark ocean, connecting galaxy clusters in a dance of cosmic choreography. Supercomputer simulations, like those from the illustrious TNG project, recreate this web with stunning detail, showing how gravity sculpts the universe's skeleton. Isn't it breathtaking to think that every galaxy, including our own, is a bead on this infinite string, bound by forces we can't see? Observations from telescopes like the Sloan Digital Sky Survey have mapped millions of galaxies, revealing this web in 3D, a testament to human ingenuity and technology. But within this structure, dark energy plays its counter role, stretching the web thinner as the universe expands, potentially leading to a future where galaxies drift so far apart that the night sky dims. Pause here and imagine looking up billions of years from now. Would a sky with fewer visible stars feel lonely, or would the mystery of that vast emptiness inspire new wonder? This balance between creation and separation, between dark matter's embrace and dark energy's push, shapes the environments where planets form, where life might emerge. It's a reminder of how interconnected everything is, how the largest scales of the cosmos influence the smallest seeds of possibility. As we reflect on this cosmic web, Let's narrow our focus to the nurseries of stars and planets within it, exploring how these grand structures give rise to the delicate cradles of potential habitability. Let's drift closer now, from the sprawling cosmic web to the intimate cradles of creation. Nebulae, the stellar nurseries where stars and planets are born. Picture a vast cloud of gas and dust, like the Orion Nebula, glowing with ethereal hues of pink and blue, illuminated by the ultraviolet light of newborn stars within. These clouds, often spanning light years, collapse under gravity's gentle nudge, often triggered by a nearby supernova's shockwave or the ripple of a galactic spiral arm. As they condense, they spin, forming a protostar at the center surrounded by a swirling disk of material. Can you visualize this cosmic ballet, the dust grains sticking together, growing from pebbles to planetesimals, and eventually to planets? This process, observed in stunning detail by the Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile, reveals protoplanetary disks around young stars, with gaps carved by forming planets. It's like peering into a construction site for worlds, each one a potential home. In our own solar system, 4.6 billion years ago, Earth emerged from such a disk, a molten ball cooling over eons into the blue gem we know. But not all worlds are so lucky. Some are scorched by their star's heat, others frozen in eternal night. The James Webb Space Telescope, with its infrared eyes, is now studying these nurseries, uncovering the chemistry of planet formation, detecting water, methane, and complex organic molecules that hint at life's building blocks. Isn't it awe-inspiring to think that the same processes crafting Earth might be unfolding across the galaxy, perhaps in the TRAPPIST-1 system, where 7 Earth-sized planets orbit a dim red dwarf? Reflect for a moment. What kind of worlds do you imagine forming in these distant clouds? Do you think life there would mirror ours, or be utterly alien? As we hold this image of creation, let's consider how these nascent worlds evolve, shaped by their stars and the cosmic environment, into places where life might one day bloom. As we continue our journey, let's follow these fledgling planets as they mature, exploring the delicate path to habitability. Imagine a young world, fresh from its protoplanetary disk, bombarded by asteroids, its surface a cauldron of molten rock. Over millions of years it cools, perhaps forming oceans as water outgasses from its interior or arrives via icy comets, a process we believe shaped Earth. But habitability is a tightrope walk. A planet must orbit in its star's habitable zone, where temperatures allow liquid water, as seen with exoplanets like Proxima Centauri b, just 4.2 light-years away. Yet, distance alone isn't enough. An atmosphere must retain heat without suffocating life, a balance Earth achieves with its mix of nitrogen and oxygen. Technology like spectroscopy, used by missions such as the upcoming Habitable Worlds Observatory, lets us analyze distant atmospheres for biosignatures, gases like oxygen or methane that might hint at life. Picture a world with a sky tinged green from exotic chemistry, or one where volcanic activity sustains a warm climate despite a distant sun. Could such a place harbor life? Earth's history offers clues. It endured ice ages and greenhouse extremes, yet life adapted, from single-celled organisms to complex ecosystems. Planetary science facts show us that habitability evolves. Mars once had flowing water, evidenced by ancient riverbeds imaged by the Perseverance rover, but lost its atmosphere to solar winds. What does this fragility teach us about our own world's future? Pause and reflect. If we found a habitable exoplanet, would discovering life there change how you see humanity's role in the cosmos? As we ponder this, let's expand our view to the challenges of detecting such life, grappling with the technological and philosophical hurdles of reaching across the stars for a sign we're not alone. Now, let's turn our gaze to the forefront of our quest, the search for life beyond Earth, a pursuit blending cosmic wonder with cutting-edge technology. Imagine the thrill of detecting a signal, a flicker of light, or a chemical signature from a distant exoplanet that screams life. We're on the cusp of such discoveries with tools like the extremely large telescope ELT, under construction in Chile, set to capture direct images of exoplanets by the late 2020s, revealing their surfaces in unprecedented detail. Spectroscopy, already used by the Hubble and Webb telescopes, dissects starlight passing through planetary atmospheres, hunting for telltale signs. Oxygen paired with methane, a combo unlikely without biological processes. But the search isn't just about light. The SETI Institute listens for radio signals, scanning the skies with arrays like the Allen Telescope Array for patterns too complex to be natural. Picture a scientist's quiet excitement as a signal emerges from the noise. Could it be a greeting from another world? Yet, the Fermi paradox looms large. Despite decades of searching, we hear only silence. Theories abound. Perhaps life is rare, or civilizations self-destruct, or they communicate in ways we can't yet fathom, like quantum signals or neutrino bursts. Reflect for a moment. What would hearing from an alien civilization mean to you? Would it unite us as a species, or spark fear of the unknown? Science pushes forward, with concepts like the Breakthrough Starshot Initiative aiming to send tiny light-propelled probes to Proxima Centauri within decades, a testament to human ambition. These exoplanet mysteries drive us to innovate, from AI algorithms sifting through telescope data to future missions like LUVOIR, designed to study Earth-like worlds. As we marvel at these frontiers, let's consider the ethical implications of contact and how our search reflects not just on the universe, but on who we are as explorers of the unknown. As we near the edge of this expanded journey, let's linger on the profound questions our search for life raises. Not just scientific, but ethical and philosophical. Imagine we found a habitable world, teeming with alien ecosystems, or received a signal from an intelligent civilization. What then? Do we have the right to interfere, to send probes or messages, potentially disrupting a world unaware of us? Picture a debate unfolding on Earth, weighing curiosity against caution, much like the protocols developed by SETI for post-detection scenarios, which urge restraint and global consensus. Our history of exploration on Earth, sometimes marked by harm to indigenous cultures, casts a shadow. Could we repeat those mistakes on a cosmic scale? Yet, there's wonder in imagining a dialogue across light years, sharing knowledge with a species as curious as we are. Reflect on this. How would you want humanity to be remembered by another world? As gentle explorers or reckless intruders? Technology like interstellar communication lasers proposed by projects such as METI, Messaging Extraterrestrial Intelligence, could one day bridge these gaps, but it demands wisdom. Meanwhile, our exploration shapes our future here. Missions to Mars, with rovers like Curiosity uncovering signs of ancient water, and plans for human colonies by SpaceX, push us to think as a multi-planetary species. planetary science facts remind us that protecting Earth remains paramount. Every exoplanet discovery underscores how rare our home is. As we dream of the stars, let's also dream of unity, of a humanity that explores with humility. I'd love to hear your thoughts. What ethical lines should we draw in our cosmic quest? How do we balance discovery with responsibility? Share your reflections in the comments. I'm eager to continue this conversation. If this deeper dive into cosmic wonder and exoplanet mysteries resonated with you, please like this video to help us reach more dreamers. If you're inspired by Earth with nature, subscribe and hit the bell for more journeys into the unknown. Together, let's keep gazing upward, nurturing our awe, and shaping a future worthy of the universe's grand story. Until next time, stargazers, let the cosmos inspire your every step.